So, refactoring, something every developer wants to do, but ends up not doing most of the time. Well, what is refactoring? Why should you refactor? And what are the different ways that you can refactor your code easily and quickly? Hello and welcome to my channel. My name is Sarang, and in this video, I'm going to answer all these questions along with some examples. The most common definition of the refactoring is to change the internal structure of the source code without modifying its external behavior. Why should you refactor? It makes your code more reusable, it removes code duplication, it also reduces code complexity, hence making it more understandable and readable. It also makes your code more maintainable, especially when the code base increases in size. The best way to learn refactoring is by actually doing it. So in this video, I'm going to explain some of the types of refactoring which I find very useful. Let's get started. I've created a sample Node.js project in TypeScript, which I've also pushed to GitHub. The reason for choosing TypeScript is that it is easy to understand and widely used by many people. Also, unlike JavaScript, it has typings in it as well. The project has several files created for demonstrating how to refactor. I will open each and every file and see what I can refactor and explain to you why I did it. Also along the way, I will identify the type of refactoring that I have applied, which will give you a practical example rather than a theoretical explanation of the type. Alright, so let's just try to understand the project structure first. As the project is a TypeScript project, so there is a tsconfig file, a package.json file, prettier is just for the formatting, and then the main folder where we would be working is the src folder. There is an index file, there is nothing in it, and there is an original folder. So I was thinking I'll keep the non-refactored files inside the original one and then create a new folder where I'll put the same file, but we'll start refactoring it. The first one that I'll start with is the e-commerce agent. This is a simple class which has a couple of methods in it. All of them might not make sense because they're just examples. Most of them would not even have a body to run the functionality, but that's not our motive. Our goal is to refactor the code and make it simpler to understand and learn along the way. So I'll start with the method place order. So let's just see what it does. The place order method again is a method of e-commerce agent. By the sound of it, it means that somebody is trying to place an order, and it accepts two parameters. One is user, second is item. Let's just see what user does. I mean what the user object is. There is an interface created for it, an ID and a name, and there is a cart item which has ID, name, and a price. So the place order first of all checks if the item's price is greater than the wallet balance or not. So if it is, then it throws an error saying not enough balance. Second, if this condition is not met, that everything is fine, it goes ahead and pushes the sent item to the carts item, which is an array of cart items. So I was trying to just resemble the cart wherein we push items just like how we do it in Amazon. And then the second thing that I'm doing after this is to deduct the money from user's wallet, for which the price is subtracted from the balance of the user. After which the item is being sent to the user, which is which is checking if it can be delivered to the user, maybe based on the location. Then if it meets the requirement or the conditions of the method, it sends it out for delivery, which accepts item and the user. For an example, if the user has the address and then the item goes there. Again, the functionality is not the main motive here. If the item cannot be delivered, the balance is so the cost is again added to the balance. That means the amount that was deducted in the beginning is credited again in the user's wallet, and a message is printed. Pretty straightforward, not a complex method. So yeah, so let's just start refactoring this method and see how we can improve this. So first thing that I'm going to do is create a new folder. I'll call it refactored. Well, this is not something you should do when you're refactoring code. You're supposed to work in the same file. The reason I am doing this is to demonstrate uh, what would happen after refactoring, and we would also be able to compare it with the initial code. So I'm going to copy this, paste it inside, and maybe as it's complaining that the class name already exists, I'm going to name it as refactored. Okay, so let's just close that. All right. So the basic things that we can do here is to understand what are the different functionalities that this function is doing. Usually, when we consider refactoring, the function is supposed to do one thing and not many things. So here it says place order, and it seems like all the things that are happening here actually belong to the function. So that is all right. But it has many micro functionalities which can be broken down and uh, separated out from each other. What if let's just say this check, item price is greater than balance, and the error message that we are throwing is something that we want to use somewhere else. So let's just start breaking it down and uh, move it to their separate functions. So let's just try giving it a name. So this one is checking if the user balance is enough. So let's just say check if user has enough balance and move it here. So it is complaining because it needs item, and specifically it needs the price. So I can say price, which is of type number, and that's it. Now I can remove this code and say this dot check if user has enough balance, and I'll send the item dot price. All right, what's the next one? So it says add item to cart. So that's something we can reuse somewhere else as well. So let's just say add item to cart, and I'll give it an item which is of type cart item, and that's it. I will put this code inside this method, and there you go. So I can now say this dot item. All right, so yeah, it looks cleaner now. The next piece of code that I think can be moved out is this one, because this is specifically responsible for the delivery of the item and can be moved out of the place order, as that's not what the place order should be doing. So let's create a function which says send item for delivery, or maybe deliver item, maybe that's it. Check or maybe validate and send item for delivery. Why I gave that name is because we are checking it and then sending it. So I'm going to copy this, paste it here. Okay, so it needs a user instance, item instance, item ID, and that's it. And the cost was coming out of the item. So user as user, item as cart item. And this can be item dot price. Perfect. So now I can call it from here and send it to user an item. Perfect. So the code looks much cleaner now, and it is more focused on the names of the function. So if I'm reading it from the top to bottom, I see that first thing that I'm doing is to check if user has enough balance. If it is, then I'm adding the item to cart. Then I'm validating and sending item for delivery, and also in between deducting user's wallet. Just to be a bit more cleaner, we can also move this out. So I can say deduct users balance. It requires the price, so that means I can send price. I can copy this here, this text as well, and the price can be placed here, and just remove it here. From here, this dot deduct item dot price. Perfect. Also, validate and send item for delivery has checking of if whether the item can be delivered, and send item for delivery, send for delivery. But this functionality is something which the validate and send item for delivery should not know about. So this is something that I can call as credit user, or you can say revert deduction, and it also requires the price. Oops, yeah, price number. Revert deduction. So here we go, and I'll call this like this. Item dot price. All right. Okay, so far what we did is we broke down the entire place order function into 4 sub functions, and the type of refactoring that we just performed here is known as extract method refactoring. The extract method refactoring is to extract the functionality inside a function which can be grouped together and given a name without changing the code here, which we also did not do. We just changed some variable name or the way we were using them. That's it. And that way we are not changing the functionality, but we just made it more cleaner and more expressive. All right. So as we have refactored the place order method, it looks much better now compared to what we had in the beginning. If we just check it again, this is how the method looked. If I open the method, I cannot understand what all is happening unless I go through each and every line, go through each and every comment to understand it. It looks much better now. Pretty good. Okay, so the next thing that we can do now is to understand what's going on in this entire file. There are a lot of functions which are doing different things. So first thing that I'm going to do is move out these interfaces in their separate files, which will definitely help in cleaning up this e-commerce agent file. So let's just create a folder of interfaces wherein we'll create different separate files for each and every interface that is here in this class. First is cart item. So the reason of separating them out is again reusability, because it's not just this class where I want to use cart item, maybe some other class might need it. And also it would look much cleaner because right now this file does not make it clear what this file is doing. There is a class, there is an interface, and usually the file should start as class on the top. So yeah, so let's start doing that. I'm going to create one more interface, which is wallet, and I just copy this. I'm also exporting it so that I can use it anywhere. The last one is interface. This is also just like extracting out some piece of code, but it's not exactly extract method. But we are still cleaning it up by extracting it and giving it a separate file. Better. I'm also going to run my yarn compile, which is the compiler for TypeScript, so that I can also see the errors and we solve them along the way. Alright, so it's looking for the cart item. I'm going to use the IntelliSense to add the import. It's also looking for a wallet, a user. That's it. Alright, so much better. Now I have separate interface files. Okay, so that thing is done, and my compiler is also happy. Alright, so let's just try to understand the entire class, what it's doing. There are cart items which are maintained, a wallet, price, a discount, and month. So I don't understand what these things are doing, which function is using them. So it's quite uh, different kind of functionality that the same class is doing. So yeah, so let's see. This is a place order deduct. So these are because these are all used inside place order. Then there is a calculate discount, get discount by day of a week, has discount, that seems like checking whether there is a discount, check if deal is special, uh, is special deal, uh, okay, it's checking whether it's a special deal or not, get price and discount, increase price by 10, increase price by 20, withdraw funds, there is a set invoice, a lot of functionality which seems all over the place. So let's just separate out things that seem like can be moved out of this class. So the functions get discount, has discount, and also calculate discount seem to have a similar functionality which we can call as discount. So the good idea is to move these functions into a separate class, that is moving it into a subclass which has a similar functionality grouped together. This type of refactoring is known as moving out a subclass out of a very large class, which we have in here. So let's just start by creating a class named discount, export class discount, and we can safely move these methods over there. Okay, so it needs month and the price and the discount. So let's see, where is this month coming from? So the month is here, discount is here, so which is not used anywhere else. So I'm going to copy it and paste it here. It does not require the month from the parameter, I guess. So we can use the month from the class instance. Okay, it's also setting it up, so it just requires it then. Okay, what's the price? Okay, price is a parameter in the class and the interface. Perfect, it works. Although it might not make sense to have price like this, month here. All these things are done just for the sake of example. So don't worry about that. Okay, it looks better now. So what if I want to use calculate discount somewhere in the class e-commerce? So what I can do is create an object of discount and access these functions on it. So for example, if I want to use it, I will say const discount equal to new discount, and then say discount dot, oh, there is the same variable here, so let's just say object, oh sorry, I should not use this. Okay, I can say calculate discount and month might be some number. Okay, so that's how I can use it. So I can now safely remove these methods 1, 2 and 3, these. Perfect. Now we have removed the discount related methods inside the discount class. I think the next thing we can move out is the invoice related functions into an invoice class. Okay. Again, the reason for doing this is to separate out the functionality into a correct class, which helps in understanding what the functions are responsible for without even getting into the each and every line of the function. So let's just create invoice class and paste it here. I'm going to delete it. I think I need to copy the price here, and it's done. Perfect. All right, so the discount is not required. Okay. Perfect. Get price and get and set discount. I think this can also be moved out into the discount class. It also has a discount in the function. Pretty simple, yeah. There you go. All right. Deal and discount can be coupled. I think so. So let's just see. Send item for delivery. Check if the deal is special. Okay, I'm gonna copy these, paste it here, and remove. Send is called by this method, so it's all right. So let's just remove these 3 methods as well. Save it. Perfect. Much better now. All right. So now what we have done so far is created a separate class known as discount, which has all the methods here. Invoice class, which has the invoice methods in it. And e-commerce seems to be cleaning up. Amazing. Now that we have separated out the subclasses, I was just thinking this method looks quite big, and let's just see what it does and if we can refactor it out. So here we can see that for it accepts a day string, and uh, then it returns a number which seems like a discount by the day of week. So if it's Monday, it returns this number, Tuesday, this much discount, and so on. And if Sunday, this is what it does. So one thing that we can do here is to remove the if and else, because it's quite long, and it is also very quite confusing, like go through each and every if and else. And to clean it up, the thing that we can do is use hash, which are there in any programming language. Using hash, you can create a key value pair. So in TypeScript, we can either use a map class, or we can use objects. So let's just say we have an object of discount versus day. That seems good. Perfect. So what it can do is, whenever the day is Monday, it can return 0.5, which is discount for that date. So what we can do is copy this, make it a key, and make 0.5 as a value. Sorry. Perfect. So now discount versus day looks like this rather than this. Sorry. So the question is, how will I return the discount? So what all I have to do now is return discount versus day and send the day. Perfect. Now I can remove this, and it looks much better, isn't it? So again, rather than keeping it here, if I want to use it somewhere else in any other method, I can take it out. I can put this value over here and just return this dot discount versus day. This looks much cleaner and compared to what we had earlier. Amazing. So what we did is we used hashes, uh, as it made sense to use it here, and cleaned up if and else. Fantastic. So in the discount class, we have a lot of methods, uh, and if we try to access these methods from outside the class, which is, let's just say, from here, for example, the way we did, and we have all these methods accessible here. But think about it, does it make sense to show discount versus day, and all the other month and price as well? No. So the next type of refactoring that we can do is uh, to hide certain methods and only show the ones which make sense and which should be allowed to be used outside the class. So first thing that we can do here is make these variables private. There we go. And I can see that the send method is something which only this method is using. So I'll also make this private. Get price and set discount, has discount. Yeah, looks much better. So now if I try to access it, it looks cleaner, and the person who is using it, for example, any other developer is using it, can only see the methods which make sense and will not end up changing some value inside the discount class which should not be changed. Amazing. So we are doing great here. The next type of refactoring that I think that we can do in the discount class is to separate out setter and getters. So I can see a method here which says get price, and set discount. It's not, I mean, it's something that is doing nothing wrong here, but what if you just wanted the price? Can you do it here? No. And what if you only wanted to set the discount? So that's again not possible right now. So what I'm going to do now is to decouple this function, which we can call as a decoupling or decoupling refactoring. So one of the things that refactoring does is to make your code uh, to have much more separation between different sort of functionalities, which we also call as decoupling of functionality. So let's just try to create two separate methods out of this, which is get uh, get price this, and it should not take anything and just return the price. Perfect. And the second one as set discount, which has no return type. So it looks much more cleaner now, as it is returning something, which is the price. It should have a return type, which is number. And as this is not returning anything, we can keep a void in the end. So what we did is we decoupled a function and created two functions out of it, which had very specific functionality. So that's a very good way of refactoring a function. Fantastic. So the next method that I can see here is check if deal is special. Okay, so what it does is there is some check, which is check if price is greater than 100. Okay, return true, else return false. Perfect. If it is true, then multiply the price by 0.95. Again, there is no logic behind it, but it's doing something. And then sends something. So maybe something it is doing after setting the total price. Else it says it multiplies the price by 0.98 rather than 0.95 and again sends something. So one more refactoring that we can do here is remove the duplicate code that we have here, which is in any if and else, if you're calling the same method repeatedly, you can actually move it outside the if else and keep it like this. So in both the cases, if we go back, we were anyways running it or calling it. What we did now is we moved it out and reduced 2 lines of code, and it looks much cleaner now. So this means if my deal is special, then do this, increment the total by this, and this else increment the total by this, uh, and in the end just send, because this is irrespective of if else. Perfect. So let's see what's happening inside is special deal function. It is returning me true or false. So that means it can give me a boolean as a return. And if we see here, it is checking if the price is greater than 100, then it's a special deal, else it is not. So with any if and else, if you're returning true or false based on a condition, you can refactor it to, as this anyways returns true or false, that is how if and else works, you can keep it like this. So if price is greater than 100, it will return you true, otherwise it will return false. So here we go. So I simplified the if and else and made it much more cleaner. So this is using the syntax of the language and making it much more cleaner, more understandable, and definitely reduce the number of lines of code. Perfect. Our discount class now looks much better. I can see one more type of refactoring that we can perform here is to remove this temporary variables. So temporary variables are nothing but one more line of code that we add just to access one of the value on an object and then use it throughout the function's body. So there's nothing wrong with using this, but we have added additional variable, which, let's just say if there were a lot of lines of code here, maybe 5-6 lines of code, somebody would always have to come back to the initialization of the variable to understand what that variable is actually holding inside it. So that is again creating some complexity in the program. So I'm going to remove this and replace it like this and remove this. So this has made it more cleaner, and it also has removed the addition of one more variable which did not make sense for us. Perfect. All right, so let's go back to our e-commerce agent. The discount class looks good. Okay, on the bottom, I can see two functions saying increase price by 10 or by 20. So these methods are very bad idea of writing code. I know it's an extreme case. I added this example just to show you one more type of refactoring that you can do. This is very simple one where the number is here, but usually we end up making different cases of a similar functionality based on maybe one value changing. So we give that in the function's name. So in order to refactor this function, we can create a new function and parameterize the value which is being changed, or which is a bit different in both the functionalities. So we call this refactoring as parameterizing a function and making it combining a couple of methods into one method just by adding a variable as a parameter coming in the function. So let's just say increase price and accept the price as a parameter, and let's just add this here. Perfect. Now if you ever had to think about this method, if you ever had to add 30 in it, you had to add this and this, but you never have to do this with this method. And for example, you can just add a comment saying increase the price by the value parameter, maybe just a bit more explanation. Perfect. Now I can remove this. It looks much more cleaner. So the next method here says withdraw funds. It accepts the amount and checks if the amount is greater than the wallet balance, which is user's wallet balance, and if it is, that means the user cannot withdraw that much of amount. Hence saying okay, this is a negative case, so negative means as a false. All right, that's an error. You're not allowed to withdraw amount more than what you hold, and if it is smaller than the balance, then just deduct it and return 0. That means a success. Sometimes we end up doing this where the return type defines the success of a method. You can also say, oh, why are you returning -1 or 0? Why don't you return a boolean? Okay, I can do that too, false or true. But it only makes sense if you're doing anything with these values. But do you really want to do something with the value when you're saying, I want to withdraw funds? That's all the function is supposed to do. One more thing that we can do here, which is a refactoring by adding error messages in your code rather than handling the cases by the use of uh, special codes, true, false, -1, these things. So how would we do that? So let's just say in this case, uh, amount is greater than the balance. So rather than returning anything, we can say throw new error and add a very descriptive message which says not enough balance, right? And just remove the return. Else just debit the balance and it has no return type. This seems more descriptive and it makes sense to throw an error because it is a case valid for throwing an error because somebody is trying to debit or you can say withdraw the amount which is not there in the wallet, which is a case very valid for throwing an error. Perfect. So withdraw funds now looks much more sensible to me. We can also privatize a couple of functions here. For example, these functions, just the way we did it in discount, uh, makes sense because they are used by place order method only. So I'm going to make them private. Perfect. So now they can only be used by this method. Amazing. So now this e-commerce class looks much better. I'm sure this can be improved much more because right now the functions are just dummy. It doesn't make sense. Most of them have a dummy code inside it. But I'm pretty sure you are getting a gist of how the refactoring works. So far we refactored the e-commerce agent class, but there is one more strategy that I would like to show you in this video, for which I had created two different classes. One is bike and one is car. So let's open these. I'm going to open them side by side just to explain what they do. So these are the classes, and they have a move method, stop, and get number of wheels. So they are actually the same methods in both the classes. So let's just say if I look into the first one, it is actually accepting the same thing. It has the same name, and it seems like it's doing the same thing as well. For now, I'm pretty sure the movement would be different for bike and a car, but just for the sake of this example, I've just kept it same. Also, the stop is same, but the get number of wheels is different for both of the classes. It's returning 4, it's returning 2. So how can we make this one better? And should we even make this better? The question is that. Yes, we should definitely do that because if we see here, we have a duplication of code. As I explained in the beginning, refactoring is a way where you remove duplicate code, and that's something you do not want when your code base is expanding. The thing that we can do here is either take out these functions, put it in a separate class, and use it from there, or give it much more logical structure and use inheritance as a way of refactoring this kind of scenario. So let's see what we can do. So I had also created a vehicle class, as bike and car both are a subclass of vehicle. See, there is already some methods which we are going to ignore for now. I have added them for another example, but yeah, I'll still explain it, how we can actually have refactor the bike and car by using a parent class and use inheritance to refactor it. So as these methods are same for both car and vehicle, I think I can move them to the vehicle because vehicle does move and stop, and extend vehicle inside the car class. But before we do that, I want to make sure whether I'm able to actually access it. So let's just say I create a method as test movement. What it does is it just moves the vehicle forward and then stops it. Very simple code. Now I should be able to access these methods even if I moved it here, which is what the inheritance does, if I delete it, see, it's gonna throw an error, but I can extend the vehicle class and still have access to it. This cleaned up the car class drastically. It removed two methods, which we can also remove from here. If I show you extends vehicle and just remove it. Perfect. I can also have this method here. There we go. So as we can see now, I can actually access these methods even if I'm in a car class or a bike class, as I'm extending it from a parent class. So this is how inheritance can help you clean up the code in subclasses if the code makes sense to be used on in between the subclasses and it has the same functionality. However, we can also see that the get number of vehicles is different for both, but it is there. So what you can do is make it an abstract class and have a abstract method as get number of wheels, which returns number. Okay, as an abstract method does not have a body, this says that there has to be an abstract method get number of wheels, but it does not define the functionality. So this gives you a flexibility of having a different sort of functionality in the body, but still it makes it compulsory to use it in the class. Let's just see what happens if I remove it. See, it says, if I hover on top of it, implement inherited abstract class. Okay, I click on it, it says get number of vehicle is not implemented. So I can just copy this and paste it. So defining a parent class and planning your code beforehand is very important because then you don't have to write the functions again, because mostly the IDE does that for you. And you also do not make spelling mistakes between the classes. So let's just say if I had a wrong spelling here, this would again throw an error. See, it's not implementing it properly. And also I can put a number here. Yeah, so this does the work. It looks pretty good, right? So bike and car are now refactored using the inheritance refactoring. So if you remember, I also have these methods here which have just something like this is an empty method, but this one is just a method which has two cases, a type of car and bike, and based on the type it returns something which is different for both. So obviously I know that speed is not calculated like this, but I still wanted to show you an example. Something like this can also be made an abstract class, abstract method, because this has a different sort of functionality for different subclasses. Rather than having a case like this, which will complicate things. If you have more cases, you'll have to create a lot of switch cases. You can put it inside the child class, or you can call it subclass. Let me just show you how to do that, and uh, handle the cases separately. So let's just say I first of all that you need to do is make it abstract. The error would be thrown because you do not have to write the functionality, and now you don't have to pass the type. And in case of car, let's just save it. It says okay, implement. Alright, before I do that, it also returns number, so add number return type. Yeah, if I implement it, it says okay, now I'm supposed to return something. Return 2 multiplied by 10. That's it. Get speed is done. And there is a car. It also requires it. Perfect. Now it returns 4 multiplied by 10. There we go. Now you can easily remove this, and there you go. So amazing. So now let's just test whether it works separately for different sort of vehicle type. So if I go back to, let's just try to use it here in index. Let's use it. I try to create an object of car, new car. There we go. Right. So I have a car. Now let's just say, what does the car.getSpeed return? Console.log. It should be 40, I guess. Yeah. Let's just run the server. Let's see. 40. There you go. I'll increase the size for you. There we go. The 40 shows that the car speed is 40. If I create an object for bike, and now I use bike.getSpeed, it says 20. So that's how you separated out the body for different of the same function but for different cases, that is subclasses. And you didn't clutter the main vehicle class, which is now cleaner. It just has the abstract method name over here. So yeah, this is the way of refactoring your code using inheritance, which is very powerful, and I think this can improve the code structure a lot and give a lot more meaning to your code base. It feels like a great achievement, cleaning up the code, making it more sensible. I hope you liked the video and learned something great today. Please subscribe to the channel for more videos like this and hit that like button to support the channel. Thank you.